I'm going to talk about relations and functions. So these look like coordinates on a coordinate plane. You have x values and you have y values. And this is kind of where this is going to run to, okay? If you could sit there and look at it this way, the domain will be your x values. That's the domain, right? The range will be the y values, right? So when you sit there and look at something like this, a set of scores or a set of numbers, right? That's the set stands for, right? This is what you're putting into an equation, and this is what you get out of it. And I'm going to do some of these problems you're going to see. I actually don't like putting the table like this. I'm going to do the table the way I kind of learned it, which I think looks a little more coherent to me, right? So a function basically is kind of like a machine, a mathematical machine. You put something in, you get something out. There is something called a vertical line test, which I'll show you actually in 6-1, that determines whether or not it's a function. But the rule is for every domain, right, you can only have one domain having only one range. So for example, if I put a 2 in, my answer for that, if I did the machine correctly, if it's something, it would be -2. You cannot have 2 producing another number, such as a 4. If this happens, it's called not a function. It becomes more inherent when we look at some of the things we're going to be working on, right? So let's take a look at this guy over here. I'm going to show you how to do one of these, then the rest are pretty easy, okay? And then eventually we'll be doing stuff on the calculator. So the first one says my function f at x and x plus 3. So what I want to do is put my x values here. I put my function, which I call my machine, x plus 3 here. And I'm going to put my y coordinates here. I know it's a little ahead of the game. This is not the way they're doing it, but I think you might as well start off showing it this way. The rest of it's going to make a lot more sense when you start doing it, okay? Now, it tells me to use the numbers -2, -1, 0, 1, and 2. And I'm just substituting in everywhere there's x in my equation, I put that number. So I put -2 plus 3. Well, -2 plus 3 is 1, okay? Next one is -1 plus 3. -1 plus 3 is what? 2. I put 0 plus 3. That would be a 3. You see what's going on here, right? 1 plus 3 makes it 4. And the last one is 2 plus 3 makes this 5. And that's, when it's written out, you would say the range of this are these values I just marked as y. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, okay? So that's how that would work. When you see something like this, you multiply it. In this case, the first one would be -2 times 2. Then you add 1 to it, which -2 times 2 is -4 plus 1. The answer with that would be -3. And you're doing the same thing over and over again, right? So the next thing you want to do is look at something of whether or not it's a function. Okay, this says it's a function because there's a 1-to-1 ratio as far as your domains, 1, 2, 3, and 4, each produce a different value, right, in your range. 3 is different than 7 and 11 and 14, right? So they're all different. If you look at this one, I just got to show you one of these and it makes sense. See how there's 2 2s? 2 cannot produce a 4 and a -4. That means not a function. Makes sense. You can't put 0 as producing 3 and -3. That makes no sense. That is not a function. And we'll show you when I do graphing how that comes out. In the graphing circle, anything, it's called the vertical line test. It's so easy. You take a vertical line, they give you one right there, and you move it back and forth. Does it ever hit 2 aspects of the line? No. If it doesn't, it's called a function. When you look at this guy, we got a problem here. Look at this. Right? I'm going to do this one for you, right? If I was to put the coordinates for this and the coordinates for this, right? It's 1, 2, 3, 4 is my x value. And then my y value in the first case would be 4, 2, right? And it's also 4 minus 2. So this is not a function, okay? So that should be fairly apparent. You draw a line and it covers 2 different parts of the curve, and there's no way there's a function. You can look at these and figure these out, right? Okay. Then these right here are just word problems. A function for our 2 pi r represents the relationship between circumference of a circle r and the radius 2 pi r. Find the circumference of a circle that has a radius of 3 feet in terms of pi. Well, radius is 3 feet, so what do? You say f at r equals 2 pi r. My r equals 3. And obviously you would put it in, okay? I'm going to let you try to figure the last one out on your own. This pretty much covers at least 6-1 to get you started.